Hi, this is Durvashwest. The topic of the presentation is design and development of the soft lower limb exoskeleton. A quick background. Exoskeleton have been around over 5 decades and it has helped people with disability for years. Traditional exoskeleton as shown on the right image are very bulky, heavyweight, and very not comfortable and does not provide good flexibility. A soft lower limb exoskeleton uh, incorporates soft materials and cable actuation system, which results in a much lighter, more flexible, and more comfortable exoskeleton. Application of those soft exoskeletons are uh, it can be used for people with disabilities for rehabilitation, gait training by military and normal people just to boost the strength and endurance and carry heavier loads. Exo, Rewalk, and Hall exoskeleton are some of the leading exoskeletons that are currently being used by patients in the medical industry. The image on the right is Exo NR, which is a lot better than the traditional exoskeleton, but it still has room for improvements. The objective of this project is to design and fabricate a lightweight lower limb exoskeleton for rehabilitation and gait training for people with minor lower limb disabilities. Series elastic actuator in combination with DC motor, bound and cable, and soft fabric will be used to reduce the weight of the exoskeleton and allow the user for better mobility. Also, to increase the weight to strength ratio of the exoskeleton, the CAD model of the hip and knee components created in SolidWorks will be optimized by topology optimization in ANSYS. Major deliverables for these projects are CAD files of the hip and knee component on the exoskeleton using SolidWorks, bond misses stress distribution counter of the hip and knee component using ANSYS, final hip and knee component of the exoskeleton in ABS or aluminum, and assembled exoskeleton for testing. Evaluation metrics is strength to weight ratio. We want to make the exoskeleton as lighter as possible and strong and flexible and as flexible and comfortable as possible. For the methodology section, CAD files of the hip and knee component will be created using SolidWorks. Structural analysis will be performed to generate the von Mises stress distribution contour of the hip and knee component. Final hip and knee component on the exoskeleton will be fabricated by 3D printing or by machining. Resource needed is SolidWorks, ANSYS, materials, 3D printer, and machine shop access, which is available in SDSU, and board and cable and fabric will be outsourcing those components. Anticipated challenges are the size of the 3D printer or machining capabilities, since the hip components on our project are quite big, might not fit in the small 3D printer, and the machine shop could have longer lead time. So to overcome those issues, we can outsource those parts. Also, programming the parts for CNC machine and machining skills could be challenging, and to overcome the challenge, I'm planning to take machining courses to polish my skills and programming skills. For preliminary work, CAD models of the hip components are created. On the left is the CAD model of the hip component with the rigid frame on the side of the knee, and on the right, a CAD model of the hip component of the rigid frame on the front of the knee. The materials that are considered for this project are ABS, carbon fiber, and aluminum, and their properties are listed on the table. Also performed static structural analysis on those components, and on the left you can see the bond misses stress distribution counter of the component model 1, and on the right you can see the bond misses stress distribution counter of the hip component model 2. Based on the analysis, the model 2 on the right is the best suited for the project, since it will provide the best support for both knee and knee and hip, and will be more comfortable compared to the model one on the left. Significance of this project is traditional exoskeleton with full rigid support indeed plays an important role for the people with severe disabilities, but it has some drawbacks such as its heavy weight and lack of comfortability and flexibility. A lightweight a soft exoskeleton system eliminates most of the weaknesses that the traditional exoskeleton have by incorporating soft material and bar and cable power transmission system for comfort, flexibility, and reduced weight. Thank you.